So once again, everyone, welcome to today's lecture. And why did I start from the beginning of the slides? This is because we have more like a brief as to what we have discussed from the last class, which happens to be on Thursday. Then from there, we can proceed with today's class. So what did we discuss last week on Thursday? We started the introduction to SOROBAN smart contract, and we literally were able to talk about what SOROBAN smart contract is. We tried to break down what exactly a smart contract is. We made it clear that basically a smart contract is actually a Turing complete program, and you can basically create any idea. That's just what it means. You can basically create any idea and you implement all of this idea in your smart contract. That's basically what Turing complete means. But in a sense, we would probably not call it a Turing complete, but call it a quasi Turing complete, because there are some things you won't be able to do, like to run an infinite loop completely. Yeah, you might not be able to do that because of gas restrictions and all of that. So that was part of what we discussed last time. We also discussed why WebAssembly was the core, the Stellar core basically chose to have the SOROBAN execution at. And we saw the reason. And from the reason is the security, the efficiency, and the portability of the WASM. And then we moved on to seeing how easy it is to actually build on the Stellar ledger, as building smart contract and deploying this smart contract on the Stellar ledger allows you to have capability of different things. And some of the capabilities we made mention of is building a lending protocol, DEXs, asset tokenization, and so many things basically. It didn't just stop there. We also got to see that the SOROBAN smart contract also supports things like the multi-sig transactions, cross-chain interoperability, and even account abstraction. And as for account abstraction, I made mention that, okay, this is going to be a class on its own where I go deep dive, I make a deep dive into account abstraction. So we broke down what a WASM is, and we made it clear that a WASM is basically a low-level binary format. And this is exactly what is being pushed when you deploy your SOROBAN smart contract. And the lists of why we actually are using a WASM, or why Stellar Core actually, chose the compiled down WASM bytecode as what they want to use for the program that would run on the Stellar Core. And all of this is what we were able to see from last class. Then we understood that when a smart contract is deployed and the bytecode is stored, it is stored inside a contract data ledger entry. And once this smart contract is deployed, the most important thing that happens is that it has a unique ID that is attached to it. And this hashed unique ID is basically what you use to identify the deployed WASM bytecode for your contract. And also this ID is also what you use whenever you want to create or invocate new instances of your smart contract. As I've explained from last class that when you deploy your WASM bytecode, you basically have the opportunity to instantiate or initialize a new instance from the WASM bytecode. So the contract instance is deployed as a WASM bytecode, and developers can create multiple contract instances. Yes, this is what we're talking about. And each instances share the same executable code, but all of these instances have different, or should I say separate states. That is, the storage of each of these instances are different, but the implementation code, which is the executable code, is basically the same because they are all coming from the same WASM bytecode. The contract state refers to the persistent storage that holds the contract variable balances and user-specific data, basically. So all of the storage, where all of the data structures you are creating to hold the user's data or your smart contract data, whatever type of data it is holding, all of these things are what we say is different from each other, even if you initialize or instantiate so many or multiple smart contracts from the same deployed bytecode. So the contract storage, we were able to explain that the contract storage is divided into three parts. We have the temporary storage, the persistent storage, and the instant storage. Notice that I'm more like reflecting or repeating what has been discussed from last time. All of this is for much more understanding and for deeper learning, as I always say. So the temporary storage, as the name suggests, short lifespan, that is the data doesn't store for a long time on the Stellar ledger. And this kind of storage, since it is a temporary one, the cost is quite lower than that of the persistent storage. Now, just from the word persistent, the persistent storage is basically one that uses a longer time on the Stellar ledger. What does this mean? This means that whenever the smart contract is deployed to the Stellar ledger, the smart contract lives for a very long time. That is, it doesn't cease to exist on the Stellar ledger, unlike the temporary storage that is removed or deleted in the sense based on the time it is meant to live. So once it's reached the time it's meant to live, what we call TTL, time to live, it basically ends. So unlike the temporary storage, the persistent storage does not have a TTL. So the instant storage, we explained that is directly linked to the contract lifecycle. So it's literally behaves like the persistent storage, but most times it's automatically cleaned when the contract is terminated. So that's more like a review on the three different storage types that we have for the SOROBAN smart contract. Now, we got into some parts where I made mention that it's all right if you don't understand when I'm talking about this part. And that is because obviously we have to write the codes practically to gain more understanding or to have a full understanding of what it is. And this is the host environment and the guest environment. So I'll just repeat what I made mention of last time. And next class obviously would be a practical class where we would see how you basically install all the dependencies you need, like the raw stuff, the SOROBAN smart contract itself, and how you basically initialize a new folder, a new instance of the contract for you to start writing. All of these things, sorry, are basically things that would be taught in the next class, which is tomorrow. But until then, it is important, as I've always made mention of, to have this fundamental knowledge. What then is the role of WASM in SOROBAN smart contracts? It ensures that contracts can be executed on any node regardless of the underlying hardware or OS. And so whether you are using Mac OS, you are using Linux, you are using Windows, any of these OS you're using, regardless of it, it allows the Stellar core to run the node on these machines, and basically, based on the rules guiding the WASM code, it allows cross-platform portability. The host objects, we made mention of different things that is contained in the host object and the host functions. We saw that there are different data types or data structures that are inside of the host objects, things like vectors, maps, binary trees, all of these different data structure. When it is time for you to use them, you can basically think of which data structure is best to use in this scenario. And that's basically what being a programmer is, your ability to understand what kind of data structure you need to use and when you need to use it. So, contract development in Rust. So last time, this is where we stopped, and we are meant to continue from here. Contract development in Rust. SOROBAN smart contracts are written in a constrained subset of Rust, a high-performance memory language. Oh, sorry. We've discussed this. This is where we are meant to start. Contract lifecycle in SOROBAN. Yes. So yeah. We've discussed the contract development in Rust, and we explained from that class under the contract development in Rust that there are no floating point arithmetics. There's limited dynamic memory allocation. Let's go back to no floating point arithmetic. That basically means that there's no decimal point. That is, all integers don't have decimal points. They are fixed numbers. They do not have decimal point. That's basically what no floating point arithmetic is. And this should not be of concern, because basically in smart contract like Solidity for the EVM chain, I've made mention in the last class that this kind of smart contract don't allow it to. And whenever you have situations where you have to involve decimals, then you use decimals, basically decimal, that is multiplying it by certain 10 raised to power whatever number you want to use to, to avoid making use of decimals. And these things are basically called decimals. So no standard IO or multi-threading. I made mention of why it's important that there is no multi-threading. And this is because of how much memory it can use at a time. And it doesn't make sense that you are writing a smart contract that is running on 2-3 threads, and other people are trying to deploy their smart contract, but because the function you are trying to call is still running a process and the other process is not done running, then it doesn't allow the other people deploying their smart contract or interacting with the Stellar ledger interact easily. So for that reason, there's no multi-threading or standard IO that is allowed in the SOROBAN smart contract. Serialization and value encoding. Basically, the word serialization is to serialize something and encode it, then decode it. And all of this is basically important because it is easier to store an encoded data. So a serialized data is easier because it's in a kind of storage format. And so you can have like a struct with about 4 field elements, and then you serialize this, and the whole format could look like a string. And you would agree with me that it's easier to store just a string that's more like in a binary form, a string in a binary form, than to have this structure with different fields being stored like that. You see, it's easier to store it in just, in a serialized data form. And that is exactly what Stellar is actually making use of, trying to store the data by serializing it, then encoding it before storing it. So this contract lifecycle in SOROBAN. So before I move to this part, I would want to see if there are any questions from everything we have discussed from last time up to this point, because I've basically ran a review on everything we have discussed from last class. So if there are any questions, you can basically ask the question now, and then I will just answer the question before I proceed. So are there any questions right now? If there are no questions, okay, you can ask your question. You can ask your question.
Sir, you said something about cost sharing. Can you hear me?
Yes.
You said something about cost sharing with Stellar, like the cost sharing in terms of like communicating with like Stellar and maybe Solana or Stellar and EVM chains. Is that possible?
Were you in the last class? Hello?
Can you hear me?
Yeah, I can hear you. I'm asking you, were you in the last class?
Yes, I was.
Yes. From the last class, Ogaski asked this same question, and the answer I gave to him was that it is definitely possible to have this happen. it's all about you building an SDK that would create an entry point for both smart contracts to interact with each other. And that was the answer I gave to him. So does that make any sense to you?
Yeah, I remember now.
Okay, great. So I'll basically continue from here. The contract life cycle in SOROBAN. It's several stages from development to decommission. What does development to decommission mean? This means that right from the beginning of when you start writing the smart contract to the point whereby the smart contract is no longer on the Stellar core. That's more like the stages. So what exactly does these development stages look like? The first point of the stage of this life cycle is basically development. Obviously, you have to write out your smart contracts. And so the contracts are written in Rust and compiled into the WASM bytecode. So as with me saying Rust, you understand that the SOROBAN smart contract is literally a framework that was built on Rust. And so for this particular reason, you obviously have to start by writing your smart contract in Rust, and then you test your smart contracts with tools like the SOROBAN CLI to simulate your contract behavior, and also even writing out your test scripts in Rust based on your contract implementation. So that's the first stage, or the first point of the contract life cycle. That is the development. Now, the next thing you have to do is you deploy it. Now, these things I'm saying, we are obviously going to see it in tomorrow's class, where we'll be having the practical as to having the full life cycle. That is the development first. So the next stage is the deployment. What does the deployment means? This means that the moment you finish writing your smart contract, you compile it. And when you compile it, it results to having your WASM bytecode. Now, whenever you write your Rust program, just like we've done in previous classes from the different examples we've written when it comes to writing Rust, you basically have a target folder, and that target folder is basically where your compiled WASM bytecode is found. So whenever you write your smart contract and you compile it, then inside that target, you can basically have your WASM bytecode. And so this WASM bytecode is what is uploaded to the Stellar network. And uploading it means you are deploying it. And so this deployment happens, you then have your WASM bytecode on the Stellar ledger. But where exactly is this stored on the Stellar ledger? It's stored in the contract data ledger entry. So this contract data ledger entry is where your deployed WASM bytecode for the smart contract you have created is stored. And whenever it is stored, like I made mention of, a unique hash is created for you, and that unique hash is more like a mapping to your deployed WASM bytecode that contains the implementation of your smart contract. So there could be additional configurations such as setting up the admin account, initializing parameters, or authorized callers. All of these things is done during the deployment. So that's a situation whereby you want to have some things called first, some function called first, initialized first, before your smart contract start running. So all of these things run during the deployment process. The next step to the contract lifecycle is basically execution. So contracts are executed in response to transaction invocation. What does this mean? This is just removing the old grammar from it. Is just basically calling the functions from your deployed smart contract. That is interacting with your deployed smart contract. Now, the function calls could either be a write or a read call. So now interacting with your smart contract is basically a transaction. And this transaction is basically still stored on the ledger. And that's the next step, that is execution, interacting with it. A virtual machine ensures that the contract runs in an isolated environment, leveraging the host functions for operations like reading and writing to the ledger data. And this is exactly the idea of execution. And when you write your smart contract, obviously, what your users do is they interact with it, and basically, in a sense, we call it execution. The next thing is termination. When does termination occur? A termination occurs when a smart contract is no longer needed. In that sense, it can be terminated. And when it is terminated, all the associated contract instances and storage are literally cleaned up from the ledger, freeing up resources. And this can literally take us back to the idea of the temporary, where is it? Let me go back to it. Of the temporary storage. So for the temporary storage, at what time does termination occurs? Once the time to leave ends, or once it reaches the time to leave, termination occurs. And at that point, if you have your contract bytecode initialized up to 30 contract instances, where all of these contract instances are being interacted with, every single contract instance is wiped off from the Stellar ledger. And at that point, everything is cleaned. And in that sense, we could say it's freeing resources, because whoever is running the Stellar node would have a little data size removed from the amount of size or gigabytes is using to run the Stellar contract. Another thing is that contract can also undergo upgrades, allowing new WASM bytecode to replace the older version without interrupting the existing contract state. This is a very beautiful concept, because whenever you talk about contract upgrading, for those that are familiar with the Ethereum blockchain, or out in general, talk about the Ethereum virtual machine compatible blockchain. So for those familiar with Solidity, you will understand that for you to upgrade a smart contract, you would have to use certain EIPs. That is, you have to use probably EIP 1822, that's Universal Upgradable Standard, or even EIP 2535, that's the Diamond Standard by Nick Mudge. But then in this particular case, you do not need that. Instead, all you have to do to upgrade the smart contract is literally replacing the WASM bytecode that you have pushed with a new WASM bytecode. And that literally makes sense. Why? This is because the WASM bytecode is where the implementation of your smart contract lives. So all the functions that is being called from the different instances of your smart contract, all of these functions basically lives inside the WASM bytecode that is deployed to the Stellar ledger. So the moment you change this implementation, automatically you have your new upgrade. That is, you basically have your new implementations in the new WASM bytecode that you have replaced with the old one. And this basically allows the existing contract states that have been initiated before to continue working without interruption. I would ask if anyone doesn't have any question based on what I've just explained now. I hope everyone was able to get what I've just explained now. I'm not getting any response. I hope. Okay, great. Great. Thank you. Okay. Tools for contract development. Obviously, for the Stellar contracts, you need to have the tools to write the Stellar code. The Stellar core basically gave different tools you can use. And all of these tools, if you cast your mind, this we had at the beginning of this coding lecture, we made mention of these tools. And one of the tools is the SOROBAN SDK. The SOROBAN SDK literally includes so many libraries and tools that help you build and test your deployed contracts in Rust. Another tool again is the SOROBAN CLI. It's literally a command line interface that allows you to interact with your contracts, and it also allows you to do things like deploying your bytecode. That is, if you do not want to deploy your bytecode manually, you can basically use the SOROBAN CLI to deploy your bytecode and even interact with your contract. So that is, the moment you want to, you have deployed your smart contract, that is, you have deployed your WASM bytecode, and then you want to invoke this contract, you want to interact with this contract, you can basically also do this with the SOROBAN CLI. The SOROBAN local net is another thing you can do, or you can use basically for the contract development. It's literally a local instance of the Stellar network. So let's say you want to build something, and what you want to build, you don't want to deploy it to the Stellar ledger. That is the test net or the future net that everyone is using, or you don't want to even deploy it to the Stellar mainnet. You can basically run an instance of the full Stellar network. That is, you can run the client locally for yourself, and you then use or deploy your smart contract to the Stellar network that you are running locally on your machine, on your computer, basically. So this is another tool that the Stellar ecosystem have provided as tools for contract development when writing Stellar. Another thing is SOROBAN Studio. The SOROBAN Studio is literally an integrated development environment with features like syntax highlighting, debugging, and contract deployment automation. So you can basically use this SOROBAN Studio if you do not want to use other IDEs. So this particular integrated development environment has the feature for you to highlight your certain syntaxes. So certain related syntaxes are highlighted in a form, which makes it actually beautiful as a developer when you are seeing your code, in different colors. It is also good for, debugging. Another thing is contract deployment. You can easily deploy your contract using the SOROBAN Studio. One thing that comes to your mind when you talk about this kind of studio, because I'm always referencing whatever we are doing with the EVM compatible blockchain, because the EVM compatible blockchain is probably where some are coming from when it comes to learning how to build smart contracts. Okay, I think there is a hand up. Okay. Team, I think you have a question.
Yeah, just quick question. I don't know what SOROBAN Studio is.
Okay, so I'm going to send a link for you to see what the SOROBAN Studio looks like, and then you can basically go through it. But I'm just going to talk about or compare it with what is comparable when it comes to the EVM chain. I don't know if you know of, oh, it just left my head now. Let me quickly search for it. Yes, I can remember. Remix.
Or,
I don't know if you
Remix.
know of Remix for EVM. Have you heard of
Yeah,
Remix?
Remix is like a web-based
Exactly.
one.
Yes. So you can basically compare it to Remix when you're talking of the ID for the SOROBAN Studio that allows you to basically, have all the enjoyment that is. When I say enjoyment, basically all the features that Remix gives you. So for Remix, it allows you to basically deploy easily. It also highlights some things. You can even see current release of Remix. You can even see the gas prices, the estimated gas price that each function, when called, will take. So that's basically an example of what I'm talking about. So I guess Coxie also have a question.
Yeah, I have a question. Okay, you were always comparing things about with EVM chain and stuff like that. So
Yeah.
Is it that Stella only stores like assets? Is it possible to like maybe create a contract whereby you register the person's name, address, like different information, or is it just that Stella is just for different assets?
No, the answer is that you can basically use Stellar for different things. Now, if you
Serious?
cast your mind back to when I was talking about what the SOROBAN smart contract is, the SOROBAN smart contract, basically, we made mention of it as a Turing complete, but I would just say it's a quasi Turing complete state or environment Stellar has created. What does this mean? This means that you have the ability to create any implementation. So anything you think you can do on the EVM chain, like your Solidity, anything you think you can do on using Solidity, you can basically think of the same implementation and implement it using the SOROBAN smart contract.
Wow, thank you.
Yes. So give me a second. I want to try to get the Stellar Studio.
So Sayo,
Yes, I'm listening, please.
you know that Rust code we wrote last, was it a bank or school? Was it bank? No,
Yes.
book register stuff. So does that mean that just imagine that we wrote those stuff on like with Soroban, you can deploy it on Stella, and then someone can just like use it for the front end as well, like create a front end
Exactly.
for it. Oh,
Exactly. That's what I'm talking about. That is what I'm
okay.
talking about. That is what I'm
Uh,
talking about.
Because initially I thought it was just for just assets, like maybe like money stuff. That what I thought Stella was all
No,
for.
no, no. It's basically have more than that. It have more than that. It has more than that. It has access to do more than that.
Okay.
Access to basically build anything you want to build on it.
Oh, thank you.
Okay, great, great, great. So we move on to gas fees and cost efficiencies. One thing you have to think about when you're writing a smart contract is how efficient is your code. And when we are talking about efficiency, you start thinking of gas fees. You start thinking of how much it costs for just a call of a function in your smart contract. Okay, I think. Okay.
Hey, Io, how you doing?
I'm all right.
I was wondering, when you were just talking about Soroban Studio, were you possibly meaning Akashi? I don't think there's
Yes.
anything. I think people are confused because I don't think there's anything called Soroban Studio.
Oh, the SOROBAN Studio basically is okay. You know what? After this class, I'm going to send a link that explains that basically talks about this clearly.
Tim
Hey.
Baker. Oh yeah, sorry. Go ahead.
Oh, that's all right. Earlier, you talked about using Horizon, and I just wanted to point out that we changed to RPC services. It's pretty similar to Horizon and how you interact with it through the SDK, but they are two separate things, actually.
Yes, yes.
Not super important, but just wanted to point that out.
Yeah, from previous classes, I have explained and differentiated the difference between the Horizon and the RPC. The RPC is basically what you use to deploy your smart contract to the Stellar ledger. So I have explained that. I just wanted to point out more on the Horizon. So yeah, thanks, Tim, for that. So are there any more comments to be added? Can I get a thumbs up to continue then? Okay, yeah. So talking about gas fees and cost efficiency, one important thing to do, you have to worry about is the consideration for gas when writing your functions, when having a function call or having certain function call other functions. So it's important to have a consideration of how much fee it would take or how much fee is consumed whenever you are having a function call. So gas is consumed by every operation on a contract platform. That is, when you are writing the data to the ledger, it basically incurs gas, obviously. And this gas is literally calculated based on how much computation is needed for that function call. So if you have a function that does so much, then the gas fee it would take could definitely be more than that for a function that does lesser. So like I made mention of, external calls, that is interacting with other contracts or functions from other contracts, also consumes gas. So that is, if I write contract A and I am trying to call functions from contract B from contract A, in that sense, it would definitely incur gas costs. So there are different techniques to using or creating a situation whereby you have to use so much gas. So to avoid using gas, one important thing you have to do is to optimize your code. You make use of the host object like the vectors and maps efficiently. You intentionally do not create data structures that are not relevant or useful in certain situations, or for you to in fact create duplicates of data. So these types of things are what you kind of think of when it comes to the cost reductions and you trying to optimize gas. Because whenever you build your smart contract, sometimes you build it for your own personal use, but most times you build it for so many users to use. And now when you have a smart contract whereby to even have a function call for a user to interact with your smart contracts, with your DApp, it takes so much gas, then this is not user friendly. Because as a user, if I come and use your DApp and then I start, your DApp basically incurs so much gas, then I would not want to come back. I would rather want to look for a different DApp that offers the same service as yours with lesser gas. And that's why it's important that whenever you are writing your smart contract, you basically optimize the functions well. So you think of different methods you can use to optimize gas efficiently. An example, as you can see from this slide, is in a decentralized finance contract. The gas optimized algorithm can reduce the cost associated with high frequency trade or liquidation. And that's just what I've tried to explain, that, okay, now you created the DEX and your DEX is literally taking so much gas than a different DEX out there. I would not want to use your DEX. I'd rather use a different DEX that would take lesser gas compared to yours. SOROBAN is designed with the multi-chain capability in mind, and this means that it allows you to interact with other blockchains. The word multi-chain, I don't know if Coxie can hear me clearly. This is it. This is where your question is driving at. It allows you to literally have function communication with other smart contracts that are deployed on different other chains. So developers can use cross-chain bridges to transfer assets and data between Stellar and other networks like Ethereum, Polkadot, and Cosmos. And so it's so beautiful that when you have some implementations on Stellar, you can basically have the same or a different implementation on a different chain, and then you have a cross-chain interaction through a bridge. Another thing is atomic swap, enabling decentralized trading of assets across chains without relying on third-party custodians. And this is a very interesting thing because one of the biggest things that Stellar is known for is the asset, the cross-border asset, allowing you to think of moving your assets in a very, very easy way. It is built into the Stellar core, and this is a beautiful thing that Stellar has done, unlike some chains whereby you literally have to build your own DEX. Okay. Okay, yeah. I'll make sure to do that. I'll make sure to do that. Okay, yeah. It's important, as I made mention of, it's important that you ask questions. Doesn't matter, I would have to go back and re-explain it. So that's the most important thing, understanding it. So Soroban and DeFi, Soroban's flexibility and efficiency makes it ideal for building various DeFi applications. When I talk about DeFi, I don't want us to just cast our mind on DeFi as the only thing you can build on Stellar. Yeah, a list of definitely DeFi things when you talk of lending protocol, yield farming, synthetic assets, stablecoins, all of these things are under DeFi. But here are not the only use case for this Soroban smart contract. With the Soroban smart contract, you can basically create anything. You can basically think of anything. One beautiful example I made mention of in the last class is when you talk about the hospital record, having a situation whereby you build a smart contract where so many hospitals around the world can basically, interact with each other, having different patients' data. And so you can have an external call to a different smart contract owned by a different hospital, so you can share the patient's data with the hospital. So that's another use case of you can build a Soroban smart contract with. And so that's not just the only use case. You can think of anyone and open your mind up apart from the DeFi that I've been making mention of. One thing you want to also look out for when you talk about DeFi is security. Now, there are different parts when you come to talk about a smart contract developer. So you could isolate yourself as a security engineer, and this involves different security considerations when you are trying to audit a smart contract. So why are we talking about security? This is because certain smart contracts hold a high volume of finance, a high volume amount of money. And having this kind of situation, you would not want a situation whereby users lose access to their assets. And in this case, it would be important that you look into security considerations, or you consider security whenever you are writing your smart contract. So this is actually, in fact, a particular angle some developers focus on. Another thing is upgradable contracts. We've spoken about that. So we move on. Cross-contract calls. Soroban contracts can interact with one another via the cross-contract calls, enabling composability. What does this mean? This means that you have contract A, you have contract B. Your contract A can basically call functions from your contract B. I think I've made mention of this multiple times now. And so whenever we are implementing it, it becomes easier to grasp. So it's all right if you hear me mentioning some things over and over again. It's all right. It's just for the ability for it to stick more and for you to grasp the concepts more whenever we start writing the code itself. Another thing is data sharing. So apart from you calling functions from a different contract, data sharing, contract can share state or read data from each other's storage. So imagine you have a read function in a different contract, and then you try to interact with that contract by calling the read function. You can basically have access to the data on that particular contract. Another thing is event triggering. It's important. Some people actually think of events and they do not include events whenever they are writing their smart contract. But why exactly is it important that you include events when writing your smart contract? It is important because there are certain situations whereby Yes, that's what I just made mention. That's why I made mention that you can basically use functions to read the storage, not sharing the storage. As I explained before, that the fact that each you can have more than one contract instance from you can initialize more than one contract from the same. Okay, the fact that you can initialize more than one instance of a contract from the same bytecode that is being deployed, it does not mean all of them will share the same state. All of them do not share the same state. They each have their own individual states. And so when I make mention of reading from their storage, what it means is that there's a read function, and then you call the read function for it to read from the contract storage. So that's what I'm trying to explain. So yeah. Okay. Did I miss anything? But thanks for pointing that out. So it's where is it? Data sharing. Okay.
It was under data sharing. Yeah, on that screen, like your second bullet point.
Oh,
The thing about bytecode and instances was I don't know 15 minutes ago when you were talking about deploying the contracts and initializing them.
I think yeah, what you said now.
Anyways, you had already corrected the thing about instances and deployments. So I was just saying on the data sharing on the text on the screen that I'm reading, it makes it look like I could maybe directly read a ledger entry from a different contract. So that's why I was saying about getters and
setters. It's not possible. It's not possible. I think the way I wrote it out here is what made you say that. I'm going to change this, instead put it as the ability to use functions to basically read a different contract storage. Yeah, I've already said it in fact that the fact that you are so many contracts are being initialized from the same bytecode, it doesn't necessarily mean they will have the same state. Each of them have different states, and I've definitely explained that earlier. So I'll just change this, I think, just to make it clearer for others who did not exactly get, because the way you pointed it, some might also think that it can be done the same.
Yeah, I just wondered. I thought, well, maybe I was wrong. I wasn't sure, but as far as I know, and I'm one of the developers. My name's Silence on Discord, if you know me there.
You weren't clear. Tim?
What'd you say? Sorry, I'm on my phone, so I'm having trouble hearing.
Yeah, okay. So you made mention that you are what?
Oh, I said my name's Silence on Discord. I think we've talked there before.
Oh, great. It's great to have you here today.
Oh yeah, you're doing great. Thanks for doing this.
Yeah. We should thank Nomad for that.
There's somebody asking again about SOROBAN Studio and the
No, I thought I clarified that.
What's that?
I thought I've clarified that.
Oh, okay. So was it Okashi?
Yeah,
or SOROBAN Studio is separate? Oh,
no,
okay, Okashi.
When I made mention of like a studio, I was saying just when you think of something like Remix, you can think of Remix for the EVM chain as like a studio. And that's the exact idea of when you talk of Okashi, it's also like that studio you basically use for development that's easier for you to work on. So is that clarified there?
Yeah, absolutely. I'll put the URL in the chat for you, Dana.
Yeah. Testing and debugging SOROBAN contracts. Why is it in fact necessary to test? Yes, yes. So for the person asking, okay, here is the link. Yes. Okashi, yeah. It's more like a playground for you to create your smart contract and basically, work with it. Why is it important to test your smart contracts? Or in fact, why is testing important generally in software engineering? This is because of human error. As a human, the fact that you are a human means you can make mistakes. Now, when you make mistakes, these mistakes can have so much problem. So to avoid this kind of situation, it is important that you write tests for whatever you are doing. And that's in fact why in previous class, when we were still teaching or lecturing on the Rust parts, we even had classes that had to do with testing. And so even when we finished building a library management application, for each of the libraries, we tested them and the crate itself was tested. And all of this is because human error can be involved when writing your smart contract. Apart from that, you might write an implementation whereby you feel what you are implementing is working based on what you think you are trying to implement, but it might not be. So in that particular case, you have to write a test to ensure what you are testing against, that is your implementation, is doing the exact thing you are asking it to do. So there are different types of tests. You have unit tests. Unit test basically allows you to test individual components of the contract. So unit test is for just one contract. That is, you can test each of the functions inside that particular contract, and then testing the functions themselves would mean having different scenarios whereby the function you are calling acts in harmony with what you want it to do. Integration tests basically is a situation whereby your contract is interacting with a different contract. Then how do I simulate the whole idea of how my contract is interacting with a different contract? So this is literally integration test, a situation whereby you are no longer testing just one smart contract, but more than one smart contract that is interacting with each other. In this particular case, it is called the integration test. So tools like the SOROBAN local net enables developers to run contracts in a controlled environment, emulating the behavior of the mainnet. What are debugging tools? You can log tracing capabilities, emitting events, and all of this is made possible for you to test your smart contracts, basically. And so doing this would allow you to ensure that you don't deploy a buggy code to the SOROBAN you don't deploy buggy code to the Stellar core or to the Stellar ledger, I meant. It is even a beautiful thing because the Stellar ecosystem even took testing so serious because they even have the future net. Now, having the future net in mind means that they understood that before they even implement what will be added to the Stellar core, it can even be implemented on the future net before it is being used or implemented on the Stellar core. That's how important testing is. So as a developer, no matter what code you are writing, it is important that you test your code before deploying your code to the mainnet, and you even test it sometimes before deploying it to the test net where you are deploying it to. So this is how we come to the end of this slides, basically. I don't know if there are any questions from anyone else. And then we can. Yes, yes. So Are there any more questions?
Excuse me,
From
my friend. Ayomi.
Yes, I can hear you.
I joined very late. Excuse me for joining late, but can you send me the whole tutorial for? I'm a beginner. I want to learn some programming language to how to develop a smart contract on Stellar.
Okay, great. It's good for you. There's no one that is actually late because for all the classes we've had, everything is being uploaded to YouTube, and Nomad actually organized all of these classes well in Notion page, where each of the previous weeks are being stored with each video associated to it with the slides with it. Yeah, she sent the link already, so you can go through it and have access to it. So for you to write your SOROBAN smart contracts, you obviously have to get the understanding of Rust, and we've had so many classes on Rust, and so that's why we are basically moving to learning the SOROBAN smart contract itself now. And so that is what you would have to learn to, to match up with the class we'll be having from tomorrow. So I'll stop sharing my screen, and I thank you very much, team, because yes, for this data sharing side, where you made mention of the data sharing, yeah, I did not know that. Not confusing the way you pointed it out, but I hope it's clear to others. So I'll stop sharing my screen now, and I look forward to seeing everyone in tomorrow's class. I think someone made mention of something. Can you share the Rust class recording for him too? Yes, all of these classes are basically inside of the Notion page. So I'll stop recording now, and thank you very much, everyone. I